We were last discussing the topic, right? So who did we say? Key 13. So what's the story with key 13? Key 13 says to you, sir, now it tells you, sir, if you have it here, like this, right? And it's not here, then you have it like this. Okay, I moved mine like this. And you told me that you want to do it, so I closed it by bringing you the positive and giving it to you up to here. You close the box and you're not planning to charge your spring manually. So what will you start doing? You'll find that as soon as you close the box, this limit switch will be, because as long as the box is closed, also very nice. Okay, and then we come here, which means that this is for you. Here, this contact passes the positive up to here, coming here as we agreed. K13 is now closed, F20 is closed, delivering the positive to K14, and the negative is coming from below here, also leading towards K14. Is it 14, right? Great, I'll open it. 14 worked, close this contact and close that contact, so the supply reached your motor here. Great, in the first scenario, if the spring is charged, this contact LS1 will open, which means it becomes on or changes its position when the spring is totally charged. As soon as it opens, it cuts the supply to K14. K14 opens the contact at that moment here, and the motor stops charging. So this is the first scenario, which is the healthy one. The second scenario is that there is a mechanical problem with the motor, or its shaft has been replaced, making the spring too heavy for the motor, causing it to draw excessive current for an extended period. This means that the overload will activate. When the overload activates, it opens its contact 95 and 96, cutting the supply to K14. As a result, K14 drops off and its contact returns to its normal position, which is normally open. And it cuts the supply to the motor until you come to fix the problem and reset your overload. Nice? Good. Now, let's assume it's neither the first scenario nor the second one, and T14 is working. The motor is now running smoothly. For some reason, the motor's shaft, for example, is no longer. Let's say with the rotor, for example, of the motor, or this shaft has come loose from what? From your gear that rotates the motor, which is your gear that rotates the spring, or charges it, okay? All this means that it is spinning in vain, okay? So the motor is working with you. Do you have an overload? No, you don't. You don't have a mechanical problem. Nothing is causing a motor stall, but the motor is spinning in vain, so the spring is not charging properly. Or am I wrong? You told me I'm right. Okay, so what do we do here, engineer? We come here in our circuit. What do? We use a contact from K14. As soon as K14 operates, this coil, as soon as it receives a supply, what does it do? It closes this contact, and this contact then supplies power to the motor at the same time. At the same time, it closes this contact of yours. This contact of yours is connected here to a timer. This timer is an on-delay timer. What does on-delay mean? It means that as soon as it receives the supply here through the positive connection and the negative from below, as soon as it receives the positive, what does it do? It starts but does not output, meaning it does not change the state of its contact immediately. All right, what is this timer like? It's similar to an auxiliary relay. However, the auxiliary relay usually changes its contact state as soon as it receives a supply, and when the supply is removed, its contacts return to their normal state. But with the timer, as soon as you apply supply to its coil, it counts a period of time before changing its contact states. When the supply is removed, the contacts return to their normal state instantaneously, meaning immediately. Continuous meaning instantaneous, right? Great. So now, as soon as this contact closes, the timer here starts counting time. This time is considered supervision over what? Over the operation of your motor. The spring is supposed to be charged. Write it down for me. I'm giving you numbers. Write it down as 10, 15 years. How long does this timer last? 1 minute, a full minute. So during this minute, the spring is supposed to be charged. Why did you set it for a minute? Why not 15? Why not 20? It's clear. I'm telling you 15. I'm saying maybe due to the aging of your motor and so on, we set it for a minute as a worst case scenario. Okay, great. If during this minute the motor actually charges the spring, what will happen? The limit switch of the spring will... Here is Amina. The limit switch LS1 will disconnect in K14. It will disconnect in K14, opening the contact, which is crucial for the motor. And it will open the contact here. So the timer will not have finished counting, resulting in a reset. But let's assume that this time a minute has passed, meaning K14 continued to operate without disconnecting. As long as it hasn't disconnected, it means there's no overload and the spring hasn't been fully charged. Okay, after a minute, what will happen? This timer will close the contact here. After the minute passes, activating K13 here. K13 is also an auxiliary relay. We know that anything squared like this is an auxiliary relay, right? So what happens as soon as this auxiliary relay operates? It opens this contact, cutting off the supply to whom? To K14, which then opens its contact here. Cutting off the supply to whom? To the motor. In this case, what does it mean? What circuit breaker motor running time exceeded, or they call it long run time. It means the circuit breaker motor's running time, which is its operating time, has been exceeded. It means the allowed time for the motor to operate has been surpassed to charge our spring. K13's function is to cut off the supply to K14 in. Case of more than a minute passing with K14 running without the spring being charged. Is that clear? You said it's clear. Then he asked, what about this part on the side? What does this section here mean? What is this part for? He said, look, quite simply, let me just draw it for you again. What is this part for? Then he said, look, focus with me now. He told you, now you told me that K14 is running. So K14 closed this contact for you, activating the timer. The timer keeps counting. If the spring charges, this contact will open. When it opens, it disconnects the cause from K14. If it didn't open, it means the rain was still working. And the timer kept counting. After that, this contact closed. If this contact closes, what will happen? It will activate K13. What will K13 do? It will disconnect its contact from here because it is activated. When it activates, it changes the positions of its contacts, and its contact is drawn as normally closed. What does normally closed mean? It means that the assumption is that this is not working, right? You told me, right? When it disconnected, it opened. It cut off the supply to K14. When K14 experiences a drop-off, its contact will return to normal open again, and this will return to normal open again, cutting off the supply to the motor. So initially, I have disconnected the supply to the motor. Why? Because there is a problem that I need to come and see. Is that clear? If you stop here, you will have a problem. What is it? As soon as K14 experiences a drop-off and this contact opens, at the same time, this contact will also open. If this contact opens, it will cut off the supply to the timer. And if the supply to the timer is cut off, what will happen? The contact of this timer will reset. And if it resets, it will cut off the supply to K13. And if the supply to K13 is cut off, its contact will return to normally closed. And if its supply returns to normally closed, the motor will start working again automatically without anyone having to intervene. Why? Because the spring is still not charged. It will start working. So K14 will operate. The question here is, why does this happen, engineer? I haven't yet talked about the alarm circuits. I haven't yet discussed the interface of this circuit with the alarm circuits. I will tell you what K13 is used for. Don't worry. Okay. Now, K14 has started working again. So it closes this again, and it closes this and this, and the motor starts. It runs for a minute. The problem still hasn't been solved. After a minute, the timer finishes counting. It closes here. It activates K13 to separate a religion. It's 14. It opens this contact, and it opens this contact, and it opens this contact. So the timer gets reset. So K13 gets reset, and the contact returns here. Oh, sorry, the timer worked fine. Oh, sorry, the timer reset. So the timer didn't reset. This contact opens, and K13 gets de-energized. So its contact returns to normal close, and K14 starts working again. We remain in this loop for 4 minutes. Is this correct? No, of course it's not correct. So what's the issue? Oh, that's why he did what? He said, if K13 is activated, what will I do? I will take a contact from K13 itself. I will take a contact from K13 and bring it here along with a push button normal close. How do you know it's a push button? Go to the symbols and you'll find it as a push button, okay? What does it mean here? It means that as soon as this timer closes and activates K13, this coil, as soon as it is activated, will close its contact, which is part of K13 itself, right or wrong? So even if this timer's contact opens, even if it opens, it's fine because K14 opened, so it reset, or K14 here opened, and now K14 no longer has a supply. All right, as a result of K13 opening from here, the supply can no longer reach. So even if K13 does this, it goes to another path, keeping the supply running. So here, what does it mean? It means that K13 activated itself, right? Or am I wrong? Right here, the phrase that it activated itself, we call this self-latching. Meaning it did a self-latch on itself, activating itself. You might ask, if it self-latches, who will reset it? Well, it resets when you have a push button here. Above this push button, there is a push button with a lamp, meaning the push button itself is transparent with a lamp at the end. It's usually orange, or the color called amber, which is a kind of yellowish orange. The idea of this push button is that you will come to fix the problem and press the push button so that K14 will start working again from the beginning. What is the name of this track? I did self-latching on K13. On K13. Because if you didn't do this branch, what would happen, as I told you, is that every time K14 works, the timer works. The timer runs out, then K13 works, K13 turns off K14, and when K14 turns off, the timer turns off, and the timer turns off K13. So when K14 deactivates, it will deactivate, and the timer will deactivate K13. So K13 returns again, and K14 activates. When K14 activates, the timer starts counting from the beginning again, and we keep going in an infinite loop. That's why I implemented the self-latching mechanism. I think we've covered our entire circuit, a boop as a control in our circuit. All right. I believe we haven't missed anything. Good. Now I have covered my control circuit here. So what alarms can you get from this circuit? You have several alarms. Let's go through them one by one. The first alarm you have is if this timer finishes counting or if K13 activates. Both are the same. Why? Because if this timer finishes counting, it activates K13. So I take the signal from K13. This is signal number 1. All right, if you receive a signal from K13, what does that mean? It means that the circuit breaker motor running time has exceeded. This is sent to the annunciator and the PCU on the annunciator so that the operator in the GIS, when they see and hear the alarm, understands immediately that there is a problem. And on the PCU, it will be sent to the SAS and the LCS so that the operator sitting at the substation automation system or the LCS knows that there is a problem. Great, that's the first alarm. The second alarm, I have case 16. What is case 16? It operates from something called LS2. And what is LS2? It's the same as LS1, meaning LS spring not charged. So, engineer, if the spring is discharged or not charged, and I'm charging it, does that mean that as long as this contact is closed, because the spring is not charged, the motor is still charging, it activated case 16. So I should use case 16. So the alarm, yes, you will use it for the alarm, even though the motor is supposed to work and charge. I tell you that's correct, but this alarm goes to the PLC. The PLC, which is an IED, I can program it as I want. I can tell it if it receives a signal from case 16 for a time period longer than, let's say 10 seconds or 15 seconds or 20 seconds, and the spring is still not charged, then it will trigger the alarm saying spring not charged. Otherwise, it won't trigger the alarm. So I can control my programming. Otherwise, if you put it on the annunciator, it will also trigger the alarm on the annunciator, but the annunciator has a limit of 20 seconds. You can program it to be disabled on the annunciator. So if you don't program it, there's no problem. It will trigger the alarm, and as soon as the spring gets charged, the alarm will be disabled. All right, great. So the alarm means spring not charged, which is number 2. Now the overload, which is operating for K15, is alarm number 3. Finally, the last part you have here in the circuit is the disconnection supervision, which is alarm number 4. Alarm number 4, so from this circuit, you get 4 alarms. When we come to the last day, the day after tomorrow, to review the alarms, I'll tell you, let's take it circuit by circuit. The motor circuit has how many alarms? It has the alarm for the circuit breaker, motor running time exceeded, spring not charged, overload operated, and finally, the DC supervision on the circuit breaker. What is the circuit breaker motor? All right, so we have completely closed this circuit of ours. Okay, does anyone have any questions before we move on to another section? Does anyone have any questions about this part? I'm standing here and waiting for any questions you want to ask. Does anyone have a question in this round? Okay, is there a question? The last point about key 13, can we repeat it? Yes, of course, no problem. All right, here I am telling you, engineer, regarding key 13, I am just telling you now that you have the positive coming like this, and you made a use. So the positive passed like this. You close the cover box, so the positive is passing. The positive is passing, it goes like this here. Write 13 now, close normally. So the supply went to key 14. Key 14 is working. Key 14 is in the 3 contacts, this contact, and this contact here. The supply went to the motor to start the motor and charge your spring. And here the timer started. This timer is counting behind you, and within 10 to 15 seconds, the spring is supposed to be charged. So its limit switch opens, effectively disconnecting key 14 as if nothing happened. Let's assume for some reason, as I mentioned, the motor shaft slipped from the motor itself, or your gears slipped, so now there's nothing charging the spring at all. As long as the spring isn't charged, this limit switch will remain closed, so K14 stays operational. And the motor keeps running indefinitely. So what did I do? As long as K14 is operational, it means the motor is running. So I activated a timer here. This timer runs for a minute. And after this minute passes, it closes its contact. We agreed that this timer is something like an auxiliary. But when the auxiliary has a supply, it changes its contact positions. Normally open becomes closed, and normally closed becomes open. However, when the timer has a supply, what happens is its contact stays for a while with where it changes and its position changes. All right, so it changed its position nicely. And when it changed its position, what did it do? It activated K13 here. Let me tell you, it's as if this part doesn't exist. You don't see it. So when K13 is activated, what is it supposed to do? It should come here and disconnect the supply from K14. Why? Because when K14 disconnects, it cuts the supply to the motor. Why? Because the motor is just spinning pointlessly. There's no need to keep it running. I need to check what's wrong, adjust my gears, adjust the suction of my motor, and so on, right? So if K13 disconnects the circuit from K14, what will happen? K14 will open its contacts, and it will open this. If this opens, the supply to the timer will be cut. If the supply to the timer is cut, its contact will return to open. If it returns to open, the supply to K13 will be cut. If K13 loses its supply, its contact will return to normal close. If it returns to normal close, the spring still hasn't been charged. You haven't solved the problem, and K14 will start working again. It closes here and closes here, so the supply reaches the motor here. The motor starts, closes this contact, and closes who? It also closes this contact along with them, so the timer starts. When the timer finishes counting, it closes here to activate K13. When K13 is activated, what does it do? It opens the contact. If the contact opens, it disconnects the supply from K14. K14 opens here and here, cutting off the supply from the motor. It opens here, cutting the supply to the timer. The timer disconnects the supply from K13. With K13 disconnected from the supply, it returns to normally closed. It returns to normally closed, reconnecting the supply to K14. K14 starts, and we remain in this loop continuously. As soon as the timer activates K13, regardless of what happens, I will make K13 take its own contact from what is operating with its coil. This means as soon as its coil is activated, it will activate its contact. So if you operated it, you were creating another path here that activates K13. So K13 remains active with you all the time. So even after K14 disconnects here and K14 stops the timer, K13 continues to operate and hold itself, which is called the self-latch. Also, if it remained in the self-latch like this, It remained closed on itself and remained working until your attendant came to fix the problem with you. Then you pressed the push button. As soon as you pressed the push button, what did you do? You disconnected the supply from the K13. Release the K13. As soon as its coil is disconnected from it, the supply returns its contact. This is normally open. Is that right or wrong? It's done, as if nothing happened. You didn't return your circuit from the beginning and it went down like this. Don't forget it. I think that's how things are. Things are clear with me. All right.